Okay, today we are going to look at this video. It says evaluate square root of 10 plus 2 root 6 plus 2 root 10 plus 2 root 15. And solution. Now I've looked that I have inside a big square root 3 different square roots of non-perfect squares. So since I have 3 of them, so I set everything to be equal to a plus b plus c. Now let's continue. So to remove the bigger square root, we have to square both sides. If you square both sides, we will have 10 plus 2 root 6 plus 2 root 10 plus 2 root 15 is equal to a plus b plus c all squared. So, and this is equal to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. So if we compare both sides, what I want to do now, I want to compare the ones that has square root 2 root something at the left hand side to 2ab, the products part 2ab 2ac. That is, I want to have two different equations. The equation 1 now will be a squared plus b squared plus c squared is equal to 10. I call this equation 1. Again, 2 root 6 2ab plus 2ac plus 2bc is equal to 2 root 6 plus 2 root 10 plus 2 root 15. So what does this mean? This implies that AB plus AC plus BC is equal to root 6 plus root 10 plus root 15. But I know there is nothing I can do again to root 6 plus root 10 plus root 16 to separate, to plus root 15 to separate them. I can't add them together. I will only leave them like this, unless I use calculator or any other thing to evaluate them. So, but since I cannot separate them now, I am going to make assumption that AB is equal to root 6, AC is equal to root 10, and BC is equal to root 15. That's exactly the assumption I'm going to make. And with that assumption now, I'm going to have that A squared b squared is equal to 6, then a squared c squared is equal to 10, and b squared c squared is 15. So if we continue then, so I will call this first one equation 2i, second one equation 2ii, and third one equation 2ii. So now if we continue like this, now we now want to solve for a, b, and c. So from equation 2i, or from equation 1, I have that a squared is equal to 10 minus b squared minus c squared. So if we substitute for a squared in 2ii, I now have that b squared into 10 minus b squared minus c squared is equal to 6. So this will mean that 10b squared minus b to power 4 minus b squared c squared is 6. So if we multiply through by -1 and take 6 to the left hand side, we will have b to power 4 minus 10b squared, then plus b squared c squared is equal plus 6 is equal to 0. So with this now, we can have b squared, but from equation 2c, I have that b squared c squared is 15. B squared, b to power 4 minus 10b squared plus 15 plus 6 is 21 is equal to 0. So this is a quadratic equation in b squared. So the factors of 21 that will give us this is that will give us what we need here is, or that will give us -10 when we sum them, is -3 and -7. That means we have b squared -3 and b squared -7. That's the proper factorization that we need to have. So now that means b squared is 3 or 7. So now if b squared is 3, if b squared is equal to 3, then we find a squared and c squared. What will we get for a squared? From equation 2i, I will have that 3a squared is equal to 6. That means that a squared is 2. From 2i, the third equation in equation 2, we have 3c squared is equal to 15. That means c squared is equal to 5. Therefore, then from the second equation, a squared c squared is now equal to 2 times 5, which is 10. So the middle equation is satisfied. Therefore, our a squared is equal to 2, b squared is equal to 3, and c squared is equal to 5. So if you sum them, a squared plus b squared plus c squared will give us 10. 2 plus 3 plus 5 is 10. So equation 1 is also satisfied, and we are through with that. So if we continue again, we have that a is equal to root 2, b is equal to root 3, and c is equal to root 5, because what we have there in the left hand side is just sum of positive numbers, so we shouldn't play with any negative. And if square root acts on it, it will still bring out positive number. That means we must write this in such a way that our result will be positive and it will look like the original question we have. So our answer for b squared equal to 3 is a squared is root 2 plus root 3 plus root 5. Then if b squared is equal to 7, so what will we have then? 7a squared. From equation 2i, we have that 7a squared will be equal to 6, which means that a squared is a 6 over 7. Then from 2i, we have 7c squared is 15, and that means that c squared is equal to 15 over 7. But does it satisfy the middle term? A squared c squared is not satisfied. Therefore, we can't have this. A squared times c squared is 6 over 7 times 15 over 7, which is equal to 90 over 49, which is not equal to 10. Therefore, the middle term is not satisfied, and so b squared equal to 10 equal to 7 is not our expected value for b squared. So what we finally have now is a square root of 10 plus 2 root 6 plus 2 root 10 plus 2 root 15 is nothing but square root of 2 plus square root of 3 plus square root of 5. So this is the final answer we have. Endeavor to subscribe to this channel, like this video, so that you will always be among the first to get the new videos I will be dropping. Thank you for watching this particular video.